Now we're going to look at something very exciting, which is called the inclusive events. Let's consider the same Venn diagram that we did earlier. If I may remind you again, that was the problem where the two events are, when we roll a die, event A getting an even number, remember 2, 4, 6, and event B, a number greater than 3, 4, 5, 6, and then the two outcomes that was not part of these two events, 1 and 3. I now want to ask you 3 very easy questions, but I would like you to try to answer this on your own. My first question is, can you tell me what the n of A is? Please take note, I'm not asking you for the probability. I'm asking you for the n, which stands for how many outcomes in event A. Now, I'm sure at this point in time, all of you will immediately say, of course, in A, there are 3 outcomes. And that is correct. The second question is, what is the n of B? Now, the same as the n of A, how many outcomes in event B? So you don't care about any other outcomes than B only. And that is 4, 5, 6. And there are, of course, 3 of them. We just want to know how many. And then something that we discussed already is, what is the n of A or B? So how many outcomes in A or B? Now you remember that was the union, the or, remember we said, those outcomes that is in A or B or both. And how many in that part? And it's 1, 2, 3, 4 of them. So there is 4 outcomes, and I'm sure you didn't find anything difficult here. Now I want to ask you to see if the following is true or false, and that is, the n of A or B is equal to the n of A plus the n of B. Now I want you to look at those answers that we gave already, and I want you to try to answer this just by saying true or false. Is the n of A or B, the n of A or B, you see there's 4 of them, is it equal to the n of A, 3, plus the n of B, 3? True or false? And I'm sure all of you say it is false, because 4 is definitely not equal to 3 plus 3, because that is 6. The big question now is, why not? Because it sounds like it must be the same. If I take the n of A, I add the n of B, then it sounds like I must get the OR. And I want you to look at this very closely and see if you can find an answer in your own mind for why is this not true. And let me show you. When we found earlier the n of A, remember we looked at those. When we found the n of B, we looked at those. When we did A or B, we looked at those. So why is this not the same? Because when we looked at the n of A, this 4 and 6 was part of the n of A. When we looked at the n of B, 4 and 6 again was part of B. When we look at A or B, we only took these once. And can you see why there is this difference? Because on this side, 4 and 6 was added here, as well as in that one. On this side, 4 and 6 was only added once. And that's why there's a difference of 2. Now the question is there something we can do to get this to be equal? Of course, what was added twice here, and on this side only once, we need to remove once. So that means on the right-hand side of the equal sign, we need to remove this 4 and 6. Now, we can't write it down minus that. So what do we write down? We go back and say, what is this called in probability? You will remember that was called AND. So what must we subtract here? We must subtract the n of A and B. Now, if you look at the equation again, is it now true? Is 4 equal to 3 plus 3 minus, what is the n of A and B? And that is 2. And do you agree? This is now true. And this rule is called the inclusive principle. But it's not 100% finished yet, because the inclusive principle is not in N, but it must be in P. But if you understand where this rule is coming from, it makes it very easy to understand why it will be true in probability. So I just quickly revise this with you. Where do we get this from? We look at the n of A, the n of B. We look at OR, and we say, is OR equal to the n of A plus the n of B? No. Why not? Because AND was added twice on the right-hand side, so we must subtract it once. How can we change N to probability? Just by using our definition again. And please remember the definition. The definition again was the P of E is equal to the N of E over the N of S. So if I have the N of A, for instance, the N of A, how do I change it to the P of A? We must divide by the N of S. Is it possible that we can do it here? Of course, because we are dealing with an equation. And you will from algebra remember that when we have equations, we may divide by something, as long as we do it both sides. So what do? We divide the left-hand side by N of S. We divide the right-hand side by N of S. Now, what do we get from here? What is the N of A or B divided by the N of S? You remember we used that rule earlier. So it's this now, we use this rule backwards. So when this is my event, this is the N of S. So what do we get? We get the P of A or B. Because the P of A or B is equal to the N of A or B divided by the N of S. And now we do it for everyone on the right-hand side as well. Remember, this is a common denominator that belongs to every one of the terms in the numerator. So the N of A over the N of S will be equal to the P of A. The N of B over the N of S will be equal to the P of B, minus the N of A and B over the N of S will be equal to the P of A and B. And this, guys, the P of A or B equal to the P of A plus the P of B minus the P of A and B is what we refer to as the inclusive principle. It's a very, very important principle that you must please remember.